In previous video, we discussed the forward difference and backward difference operators. Now we define an operator E. What is the operator E? We can define it as let y is equal to fx be a function of x and let a plus h, a plus 2h, these be the consecutive values of x. Then we know that forward difference of fa is equal to fa plus h minus fa. This is our equation number 1. Then we define an operator E by the relation operator E fa is equal to fa plus h, and this operator E is called the displacement or shift operator. So forward difference of fa is equal to displacement operator fa minus fa, or EFA is equal to FA plus delta FA, which is equal to 1 plus delta into FA, because FA is arbitrary. So E is equal to 1, E is equivalent the 1 plus delta, or delta is equivalent to E minus 1, because this is an identity, not an algebraic number. Further again, E square second time displacement of fa is equal to displacement into displacement of fa. This is equal to displacement into fa plus h. When again we take displacement, then this is fa plus 2h. Similarly, we get n times displacement of fa is equal to fa plus n minus h. And the inverse operator is also defined. Inverse operator of displacement as defined is equal to E, inverse operator E, fa is equal to a plus h. Second time inverse operator fa is equal to fa minus 2h, and third time fa is equal to fa minus 3h. So the for n times inverse operator displacement is equal to fa minus n minus h. This is our result. What is the property and relation? Forward difference operator is del, backward difference operator is nabla, and displacement operator is E. The operator E and delta are commutative. So from displacement operator of delta fx is equal to displacement of fx plus h minus fx from the definition of delta, which is equal to displacement of fx plus h minus displacement operator of fx, which is equal to fx plus 2h minus fx plus h by the definition of displacement operator, which is equal to delta of fx plus h. So the displacement operator of forward difference fx is equal to forward difference into EFX, which is equal to E into delta. This is the equivalence of the delta into E. This is prove these are commutative. Second, again property 2, n time displacement operator is equal to 1 plus delta ki power n. We know that ya plus nh is equal to ya plus nc1 delta ya plus nc2 del square ya plus up to ncr del r ya. This is equal to 1 plus nc1 delta plus nc into delta square plus n इसी तरह से into ya, which is equal to 1 plus delta की power n into ya, but y of a plus h and h is equal to n time displacement operator of ya. So n time displacement operator of ya is equal to 1 plus delta की power n into ya. So e की power so the n time displacement operator is equivalence relation the 1 plus delta की power n. Third property, nabla is equivalence relation is equal to delta into inverse displacement operator. We know that forward difference of fx is equal to fx minus backward difference of fx is equal to fx minus h. Yeah, and we can write as this is equal to forward difference of fx is equal to forward difference of x minus h, which is also is equal to forward difference of E minus inverse fx. This is equal to delta backward difference is equal to forward difference into inverse displacement operator. Again, next property, relation number 4. Relation number 4 is nabla is equivalence relation of the 1 minus inverse displacement operator. So the nabla backward difference of fx is equal to fx minus h, which is equal to fx minus inverse displacement operator of fx. Taking fx common, this is equal to 1 minus inverse displacement operator into fx. So nabla is the equivalence relation. So the nabla is the equivalence relation is equal to 1 minus displacement operator. Fifth relation is 1 plus delta into 1 minus delta is the equivalence relation of the 1. So the 1 plus delta into 1 minus nabla into fx is equal to 1 plus delta into fx minus nabla fx. 1 plus delta is into fx minus h is equal to 1 plus delta into fx minus h, which is equal to displacement operator of fx minus h, and this is equal to e into inverse displacement operator of fx, which is equal to fx. This is equal to 1 into fx. This implies the prove the result. Sixth result, delta minus nabla is the equivalence relation of delta into nabla. We know that forward difference of fx is equal to fx plus h minus fx, and backward difference of fx is equal to fx minus h. So now delta into nabla fx is equal to delta into nabla of fx is equal to delta into fx minus h, which is equal to delta into fx minus delta into fx minus h is equal to fx plus h minus fx minus h, which is equal to delta fx minus nabla fx, which is equal to delta minus nabla into fx. So the fx is arbitrary. So delta into nabla is equivalence relation of the delta minus nabla. We can use in this properties by the separation of the symbols. Such method in which the relationship between the two operator e and forward difference operator delta then can be used to prove some useful identities, which are known as method of separation of symbol. In this we can prove it as, just prove it that in example, prove that u1x plus u2x square plus u3x cube plus is equal to x by 1 minus x into u1 plus x square upon 1 minus x ka whole square, forward difference of u1 plus x cube upon 1 minus x cube, forward difference of u1. So the from the right hand side, x upon 1 minus x into u1, x upon 1 minus x into u1 plus x square upon 1 minus x ka whole square, forward difference of u1 plus x cube bata 1 minus x cube, forward difference of second time of u1. Taking common x upon 1 upon minus x, then in equation become x upon 1 minus x into 1 plus x into delta upon 1 minus x plus x square del square upon 1 minus x square plus this into u1 is equal to x upon 1 minus x into 1 minus x delta upon 1 minus x to the power minus 1 into u1 on simplification, which gives x into 1 minus x delta ki power minus 1 into u1 is equal to taking x common, taking x as common, then we get this is equal to x into 1 minus x into 1 plus delta की पावर माइनस 1 इंटू u1 इज इक्वल टू x इंटू 1 माइनस x डिस्प्लेसमेंट ऑपरेटर e की पावर माइनस 1 इंटू u1 इज इक्वल टू x इंटू 1 प्लस x स्क्वायर e स्क्वायर प्लस दिस इंटू u1 विच इज इक्वल टू u1 प्लस x स्क्वायर u2 प्लस x क्यू u3 प्लस इस तरह से this is equal to right hand side. So using these properties we can also separation of symbol method, in which method of separation of symbol defined.